Here we go, guys. So today we got three goals. Actually, it's really two because goal number 3, solving logarithmic equations, we're going to do tomorrow. All right, so really we're going to do number 1, which is change exponential expressions to logarithmic. And then converse is going back from logarithmic to exponential. So that's going to be easy. Please write this stuff down, guys. You can use this on your test, right? Have this ready to go for Wednesday next week. Then we're going to evaluate and graph logarithmic functions. That's going to be super, super easy. So let's get started. So I talked to you earlier in chapter 5 too and said, hey, the reason why we're doing this inverse thing is because we're dealing with exponentials and logs. And an exponential equation is the inverse of a logarithmic and vice versa. So these guys are inverses. And inverse means that the x's and y's are going to flippy-flop. Okay? So if I have an exponential, if I have y equals a to the x, where x is my exponent and a is my base, and y is the number all by itself, okay, then the x's and y's are going to switch positions. The x hops on down and the y hops on over. Okay, so I get x equals the log of y base a, and that's how you read this guy. So you read the big font first, x equals log of y, and then you say this little guy is base a. This is the base of our exponential and our logarithmic function. So this is the base of the exponential and the logarithmic, okay? So it basically like makes a wheel, like the x hops on over and the y hops on over, okay? Now, that's one way to do it. Some people talk about this wheel method. I always remember this, okay? I remember exponent equals log with the same base, and then that number that was all by itself is inside of the log now, okay? So exponent equals log with the same base, and then that number. Or log with the same base, and that number is equal to the exponent. So I always remember exponent equals or equals exponent, okay? Now that's pretty important. I would star that up, box that up, highlight that. I'm a big highlighting guy. Maybe you are too. I'm gonna star that up so I got that ready to go. Okay, quiz or test time, my eyes are drawn right to that. Oh yeah, they want me to convert this thing. I can do that. So examples 1, 2, and 3, it says change each exponential expression to a logarithmic. All right, so this is 2 cubed equals 8. So I'm going to use that idea, exponent equals log with the same base, and then that number that was all by itself. Okay, all right, what's the exponent? What do you guys got? Shout it out. The faster you guys answer, the faster we get to move on. You can give me fingers. What's the exponent? Leo, what'd you say? 3. So we got 3 equals log. What's the base of that exponential? Fingers. How many fingers is the base? It's all about that base, about that base. All right, I think I saw 2. Okay, Lorelei was 2. Lisa was giving me the peace sign. And then the number all by itself is 8. So we end up with 3 equals log of 8 base 2. Perfect. Isn't that easy? All right, let's try it again. Exponent equals 4 equals log with the same base. What's the base of that exponential? That's the base of my log. How many fingers are shouted out? I'm scrolling through you guys. How many fingers is the base? Yeah, Lisa's giving me a high five. Boom. And then 625 goes inside of the log. So I have 4 equals log of 625 base 5. Okay. You guys are doing awesome. So last one, if you want these for your notes, it seems like you guys are good. My exponent is 3. My base is 7. And then 343. Okay. So again, once you know this, exponent equals, it's easy peasy. Well, now we're going backwards. Okay, so we're doing what's called the converse. So here it says now change from logarithmic to exponential. So if I have log of 81 base 3 equal 4, what they want us to do is put the base now, the exponent equals that number. All right, thanks, Paige. No worries, girl. Okay, so again, exponent equals log with the same base, and then the number. All right, so what I do is I usually start with the base. All right, what's the base of the log? What's going to be the base of the exponential, guys? Show me fingers. Or shout it out. What do you guys got? What's the base of the log? What's the base of the exponential? Ryan, what do you got? How many fingers? Guys, I can't compete against YouTube. YouTube's going to get me. Netflix is going to beat me every day. Right? Help me out. Lisa's giving me the 3. There we go. So I've got exponent equals or equals exponent. So this guy's my exponent. And now that's equal to the number that's inside, which is 81. When you convert, and these are all numbers, it should make sense. 3 to the 4th is 81. So now you know you did it right. Okay, so this will be set up right, what they give you in my math lab or what I give you on a test or quiz if I did it, on the review. So this should make sense. 3 to the 4th, 3 times 3 times 3 times 3 is 81. All right, let's do one more here. What's my base? What's the base? Morgan, what do you say? What's the base, girl? You can use fingers or use your... I got log of 1/4 base 2 equals -2. I just gave you the answer, right? So I get 2. Awesome. Exponent equals exponent. What is this thing equal to? What's its exponent? McKelvey. I got a lot of cameras up. Jess, Sydney L. What do you guys think? Connor, what's my exponent? McKenna. Amschel. -2. Fantastic. And now that's equal to my fraction, which was 1/4. Now, if I type this in my calculator, 2 to the -2, send it downtown, that goes to the denominator. I would get 2 squared, which is 4 on the bottom. This works out perfect. Okay. So a little converting. And then the final one, base is 2, exponent equals exponent is 5, and that equals 32. And 2 to the 5th is 32. Okay. Give me a hand. Where are we at? Thumb. Give me a thumb. Do we need to see more of those? I'm seeing thumbs up, thumbs up, thumbs up. All right, Gavin, welcome aboard, bud. Oh, look at Jen. She's giving me the thumbs up in the chat. Look at that. I only got 1 thumb up. Figure out how to thumb up on the chat here, guys. If you click on more on the chat. Give me some thumbs here. Yeah, give me a thumb here. Where are we at? Let me see you're there. Oh, yeah. I got 5 thumbs. 6. Oh, my God. I want to see all thumbs, guys. Give me a thumb up or thumb down. If you go to more, you can even clap your hands if you want. Be crazy. Well, you're going for a little coffee talk over there. A little coffee? You need some coffee in the coffee talk? Oh, man. All right, thanks for participating, you guys, with your thumbs. Fantastic. All right. Switching gears now. If I look at goal number 2, it says evaluate and graph a logarithmic. Okay, so I'm going to go back to the idea of inverses and this exponential function. Okay, for sake of graphing, I'm just going to use a number. I'm going to use y equals 5 to the x. Okay, so I'm going to use a base of 5. Why? I don't know. I just felt like doing 5 today. All right, so I've got y equals 5 to the x. If I was graphing this guy by hand, I would use those 3 points that we talked about. 0, 1, 1a, -1, 1 over a. 0, I'll write those out again. That little chant we talked about. 0, 1, 1a, -1, 1 over a. And now I got my base. My base is 5. Again, I just made that up. You can use any base, but I'm choosing 5. Felt right. So I'm going to go 0, 1, 1, 5, and -1, 1 over 5. So just a reminder how to graph these by hand. On the test, when you guys had some of these, some of you guys weren't putting in the base. So I would review your chapter 5153 quest and see if your graphs look right, but they're wrong. That's probably because you didn't type in what the base of this guy was. All right. Some of you guys had the shifts and everything right, but didn't type in the base. So take a look at that. Email me if you see that, you know, your graph looks pretty much right, but you didn't do the base. I'll give you some points back. Got to review it though. All right, I graphed 0, 1 over 1 up 5. 1, 2, 3, 4, 5. And then over 1 up a fifth. Okay. Reminder, there's a horizontal asymptote right here on the x-axis at y equals 0. And that graph is like a little J-curve. It starts really close to that asymptote and works its way up. Okay. Domain for this guy is always all reals, negative infinity to infinity. So from left goes all the way to left to negative infinity, goes all the way to the right to positive infinity. And then your range is bottoms up from your asymptote up. Goes all the way from 0 to infinity. And that's what we just covered. That was chapter 5.3. That's what you guys were just quested on. All right. Well, now, I've been saying it a long time. Now, we're going to use the idea that these are inverses of each other. Okay. Do you guys remember the definition of inverse? What do we do with inverses? What are we supposed to do? What's the definition of inverse? If I have a coordinate point, how do I find the inverse of that coordinate point? Use your microphones. Use the chat. Question to you guys is, what is an inverse? How did we find the inverse of a coordinate point? If you need to, take a look at your chapter 5.2 notes. We said inverse like 1,000 times on that set of notes. So again, the question is, what's the definition? No, blah, blah, blah. What's the definition of inverse? If I have a coordinate point, 0, 1, what's the inverse of that?
It would be 1, 0. You just flip them.
Yeah, we switch the x's and y's. So we switch x and y values. So if I have 0, 1, now I have 1, 0. If I have 1a, now I have A1 steak sauce. And these are A's, not 9s here, guys. And if I have -1, 1 over a, then I switch it. It's the inverse. It's 1 over a, and then -1. So use the idea of inverses. Inverses, these are inverses of each other. So I'm going to come up with just a basic equation like you're going to see on your homework. You're going to see log y equals log of x base a, and I'm going to say a is 5. Okay, you guys see that all right? Again, you want to pin me, make sure I'm nice and big here. So my a value, my base, a is 5 again. So I've got 1, 0, 5, 1, and then 1 over 5, -1. So I graph it. 1, 0 is right there on the x-axis. 5, 1 is over 5. 1, 2, 3, 4, 5 up 1. And then 1/5, -1 would be right about there. Okay. Instead of having y equals 0, I switch it. So now it's x equals 0. So I had a horizontal asymptote, now I have a vertical asymptote at x equals 0. And then my graph has been reflected over that line y equals x. It looks something like that. And again, by definition, inverse, that means my domain and my range flippy-flop. So my range before was 0 to infinity. Well, now look at my domain. From left to right, I don't see it until the asymptote. So I start seeing it at 0 and it goes all the way to the right. So my domain now is 0 to infinity. And my range, okay, is now the domain. This thing goes all the way down to negative infinity, goes all the way up slowly to positive infinity. It's been flippy-flopped. Okay, and that's the definition of inverse. These guys are inverses of each other, so I'm using these coordinate points flipped. So instead of 0, 1, 1, a, negative 1, 1 over a, we're using 1, 0, a, 1, 1 over a, negative 1. Okay. All right, so let's take that. I'm going to graph the first two here, guys, and then we're going to move on. And if we have time, we'll do one more graph. Okay, so I'm going to graph and go through these transformation ideas with you guys here. All right, as I'm graphing by hand, if I had to do this by hand, I'm going to show you what you would do normally. And then again, talk to you guys about my math lab and how you would do it. So if I'm doing this by hand, I've got 1, 0, a, 1, 1 over a, negative 1. Those are the 3 points that we had on the previous page. Okay. And we're going to take these things, we're going to move them up, down, left, and right. Now, if I see a number outside of the log, that's just like we've been doing with quadratics, moving that smiley face up and down, moving that parabola up and down. If you see a positive 2, it goes up. And if you see a negative 2, that goes down. That's a vertical shift. Okay. If I see inside of parentheses, inside of the log, in with the x, that's going to move the x's around. That's going to move it left and right. That's a horizontal shift. And if it's positive, it does it the opposite of what you think. Positive goes to the left and negative goes to the right. Again, if it's in with the x's, it's going to change the x's. This is a multiplier to the x's. When it's negative, then it's a reflection over the y-axis. Just like we did with symmetry. When we did symmetry over the y-axis, we replaced x with negative x, same idea. If the x is negative, this is a reflection over the y-axis. So if it's in with the x, it's changing the x's. If I change the x's, it gets flipped over the y-axis. And vice versa, if it's outside of the log, and I can even move this over using division and put it with the y. If it's outside a log, that means it's with the y's. That means that's a multiplier to your y's. And if it's negative, that's a reflection over the x-axis. So you can read that. Got to write small so it fits in there. Okay. And then this guy, again, is the same thing. That's a multiplier to your y's. All right, so I'm going to put this in action here. We got about 15 minutes left. Try to get you out of here early if I can. This is a longer set of notes just because of graphing and all the stuff this contains. Tomorrow notes will be way shorter, okay? So if I take a look, my base is the first thing I need to know, okay? There's a little box in my math lab for you guys to type in the base. So you need to type that in. The base of this guy is 2. So if I'm doing this by hand, that's where I start. 1, 0. A1, so 2, 1, 1 over 2, negative 1. Just using my 3 special points. Well, now I have this plus 3, okay? That is not inside, that's on the outside. So this is either going up or down. Which way is this thing going? Up or down? What do y'all say? Up or down? It's plus 3.
Going up 3.
Yeah, so I'm going up 3 units. That's a vertical shift in my math lab, and then just plus 3. If I was doing this by hand, the y-axis, this is changing your y's. I'm adding 3 to my y's. So the final points of the graph is 1, 3. 1 plus 3 is 4, so 2, 4. And then 1/2, negative 1 plus 3 is 2. Okay. I always like doing your vertical asymptote. Normally it's at x equals 0. Now it's going up 3 units, so it's staying the same spot. It's staying at x equals 0. Let me know if I'm going too fast. I count over 1 up. 1, 2, 3. I got 2, 4, so over 2 up 4. And then 1/2, really close to the asymptote, and up 2 is right there. Graph starts by your asymptote down here, and it's a J away, curves away from it. Domain and range. Range is easy peasy on these. It's always all reals. Domain is always your asymptote to infinity, unless there's a reflection. So in this case, it starts at 0 and goes all the way to the right. So it starts at 0, goes to infinity. All right, any questions on that, y'all? I want to do one more before we move on to the algebra stuff. All right, let's take a look at this one. So I've got y equals log x plus 3 base 2. Okay, so again, my math lab, they're going to say, hey, what's the base? There's a little spot for you to type that in. So look at that little guy. That little guy now is your base. So I use my 3 points. 1, 0, 2, 1 again. 1 over 2, negative 1. So I'm using my 3 points. 1, 0, A1, 1 over A, negative 1. So if I'm doing this by hand, this is what you got to do. Well, now it's inside of parentheses. And we said earlier, that's a horizontal shift. And it does opposite of what you see. So if it's plus, it actually moves it to the left because it's really x minus negative 3. And if it's a negative, it would move it to the right. So if you saw a minus here, it would move it right. Well, it's a plus. This moves it horizontally to the left. So I'm subtracting 3 to all of my x's. It's in with the x's. It changes the x's. So I do a little subtraction here. I got 1 minus 3 is negative 2, 0. 2 minus 3 is negative 1, 1. And negative 3 plus 1/2 takes me to negative 2.5 or negative 2.5 or what have you. Okay, if this is my math lab, I got to put in my base, and I got to put in that it's a horizontal shift to the left, negative 3. Okay. I always like to think about the asymptote. It was at x equals 0, and now 1, 2, 3, it gets moved. So if I have a vertical asymptote, the horizontal shift is what moves it. So I'm at x equals negative 3 now. And then I graph my points. Negative 2, 0 is there. Negative 1, 1 is right there. And negative 2.5, really close to the asymptote and down 1. Starts by the asymptote, works its way away in a J. Like a J on its side. Range is easy peasy, right? Range, negative infinity to infinity. It's the domain that's a little tricky on this one. What's your domain, guys? What's your domain? What do you got? Sydney, what do you see? Madeline, what do you guys see? Anshel, Hayden, what do you guys see for domain? Left or right? Where do you start seeing this thing? Ooh, I see it. Where do I see it at? Joe, what do you see?
Negative 3 to infinity.
Perfect. All right, so I got negative 3 and infinity. You guys good with that? All right. Now, look at where that came from. That came from this guy right here. Okay. Whatever's inside of your log is going to affect your domain, okay? So it's always going to be the opposite of what you see in parentheses and then going to the right. So we're going to use that idea. So I'm going to jump all the way to our last sets here. We're going to use this idea when they ask you to come up with the domain. So it says find the domain of each function. So you might have to do this algebraically. Okay, so anytime I have y equal a log, and inside I have a bunch of stuff, right? We're going to take that stuff, okay? We're going to take whatever's inside and set it greater than 0. Okay, I know, at least I should, that this is a horizontal shift. This x minus 1 is moving it to the right. Well, mathematically, that means it's going to be greater than 0. So whatever's inside, set that greater than 0. And then we can just solve it. We can add the 1 over, and I get x is greater than 1. Okay, so if you want to do a fancy set notation, domain is the set of all real numbers such that x is greater than 1. Okay, or look at the graph of this thing, right? The asymptote is normally at 0. It's been moved to the right 1 unit. X equals 1, and your graph would look something like this. Okay. Now, this is what's called a natural log, and we'll talk about natural logs here in a second, but this is just any old log. It's a little special. We'll talk about what that means. So this is set notation, and then if you wanted interval notation, you got to see what it wants. Then we would say from positive 1 to infinity, or just 1 to infinity. Don't need the plus in front. All right. So same idea here. Just a reminder, this is what's called a rational function. If I take x minus 1 over x greater than 0, this is from chapter 4. If you guys remember chapter 4, we did rational equalities at the end of chapter 4-6. Right? That was our last chapter. We said, hey, find the zeros on top. What makes x minus 1 0? We said 1. If you need to, set x minus 1 equal to 0 and solve it. And then we said, hey, what's the undefined value? Undefined is what makes it undefined, what makes the bottom 0. So set the bottom, x equal to 0, and you get 0. And we put those on a number line, 0 and 1 right here. And then we want to see what numbers are greater than 0, what numbers are positive. Okay. Now, you could do this by hand and choose like -1 and plug it in, plug in 0.5 or plug in 2, or you can use your calculator to do that. In your calculator, just real fast, I typed in x minus 1 over x. You can do that too. Make sure you put parentheses around whole numerators and whole denominators, and then you can graph that thing. So number to the left of 0, we said was -1. Where is this thing above the x-axis? Definitely over here. Second trace value, -1. And get +2, so this is a positive region. And then a number between 0 and 1, I could type in like 0.5, right? I get a -1, that's a negative region. It's below the x-axis. And then a number to the right of 1 would be 2, or 3, or 4, and I'm getting all positive numbers here. That's a positive region. Okay. Again, we're looking for numbers that are greater than 0. Those are positives. That's where I shade. In this case, I'm shading on the outside. It's not equal to, so it's parentheses. So from left to right, my answer for domain would be -infinity to 0. Union or, don't see it until 1. Parenthesis around that all the way to the right to infinity. Okay, so this is how you do domain algebraically. Okay, whatever's inside set greater than 0. And then from there, it's just an inequality. Most of the ones, I would not freak out too much about this one, although this is great review from chapter 4-6. I would worry about something like this. It's always x is greater than the opposite of what you see. Okay. All righty. Any questions there, guys? I know that was a little quick. Are we okay?
We're not gonna have to do the union thing in the test, right?
Probably not.
Okay.
That's good review, though. A little quick review on 4-6. Okay, you might see one of those on homework tonight, and when I make the quest, Leo, just for you, I'll make sure not to put that one on there. All right?
Thank you.
Yep. Let's finish up, guys. We got a couple more minutes left. I've got find the exact value of logarithmic without a calculator. Eventually, I'm going to show you how to do it with your calculator, but not today. The first thing you want to do is set these equal to x because we don't know what they are, and we don't know what something is. Us math guys like to put x's next, equal to it. All right, it's something that's unknown. We don't know what it is, so set it equal to x. Okay, so that's the first step. Set equal to x. Okay, then we're going to convert. If it's logarithmic, we're going to convert to exponential. All right, so remember our base exponent equals the number. All right, what's the base of this guy? This is kind of taking us full circle from the first part of our lesson. What's the base of the log? This little guy here. That's our base of our log right here. That's their base of our exponential. Exponent equals or equals exponent. So x is going to be our exponent for these. And that is going to equal the number that's all by itself. So the number inside of the log is 243. Okay. So now this takes us back. I've got 3 to the x equals 243. This takes us back to exponential equations. I want to try to get the same base. So 243, if you don't know, now you know, is 3 to a power. Is it 3 squared? Is it 3 cubed? 3 to the 4th, 3 to the 5th, 3 to the 6th? What is 243? 3 to what power? You can use your fingers here. 3 to the what? Three to the 5th, Jen says. Fantastic. And now the rule is if the bases are the same, our exponents must be equal. So we get x is 5. Okay, so if I was to type this, I know how to do this in my calculator. Log of 243 base 3, I'll get 5 when I press enter. Okay, and I'll show you how to use your calculator in the next chapter or the next section. Okay, so this is great review for exponential equations though. So I'm going to jump to 17 just so you don't freak out when you see that fraction again. Again, my base, I always start with the base when I'm converting. My base is 1/2 equals exponent. My exponent is x. And now that's equal to 8. So my base, my exponent, and the number all by itself. Do a little switchy switch. First thing we talked about, if it's downtown, shoot it uptown by making it a negative exponent. And then we said, hey, power to power, we know to multiply. So negative 1 times x is negative x. Well, that's equal to 8, and 8 is 2 cubed. So exponents must be equal if those bases are the same. In this case, they're both 2, so negative x is equal to 3. And then we can divide by negative 1. So we get x equals negative 3 there. Okay, so those should be the last few questions on your homework for tonight. All righty, ladies and gentlemen, I'm pretty much done for today. If you need to see more of those notes are all filled out online. So if you need to see more, the video will be posted later today if you need to see that again. You guys have a great day. You guys have fun.